So what we're going to do is I'm going to show you an application that I hope will kind of convince you that 7 is a lucky number. 7 is a very lucky number. And people have heard that before, and many believe that that is indeed the case. So I'm going to try to convince you of that with this little exercise here now. Okay, so as you can see, I have 4 3s and 4 4s. Okay, so I'm going to begin just mixing these. So I'm going to put them down into piles. Now, if you were here, what I would do is I would begin dealing until you tell me to stop. And maybe you tell me to stop there, maybe stop there. Stop there. One more. Okay. Okay, why don't we do another one of those? We can do as many of these as you like. Tell me when to stop. Stop. Okay. Stop there. Stop just right there. And then, okay, very good. Would you like to do one more of those? You would. Okay, tell me when to stop. Stop there. Okay. Stop after just one. Stop there. Okay, very good. Okay, and then we're just stacking from right to left. Okay, that's quite a bit of mixing to scramble these initially. And then what we're going to do is we're going to put them out kind of in a triangle configuration, which is fun to do actually. And then we'll just stack them in opposite order, which will really help to mix these cards. And now we're going to perform each of our new shuffles here today. And so if you were actually here, I would have you just randomly choose an order for each of these. Now the reality is you can actually perform any one of these shuffles as many times as you like and in any order that you like. That is the amazing thing about Bessey Sequences and Bessey Shuffles. Okay, so if you were here, maybe you would choose to do the last one first. So you might say, do shuffle 12 first. So okay, let's do that one. That's the mange under, over. So you start by putting that first card under. What would you like next? Shuffle 9? Okay, so that's the even up jog in which we stack the left pile, this one, on top of the right. What do you want next? The mange over under. Okay, we'll do that one. So you push over the top card. Now this one goes over and then under, over, under, over, under, over. Okay, and that leaves our shuffle number 10. That's an up jog as well. But this time we're going to stack the right on top of the left. Okay, and I really wish you were here because I would have you ask for more of these if you would like. Maybe you want 2 more applications of one of them or something, or 3 of them done, or whatever it might be. So why don't we just do one more of these? Which one would you like? And I'm just kind of pretending to maybe guess what you would guess, but it actually wouldn't matter. You would genuinely have a free choice in this. Okay. Oh, you like the mange over under because of its crazy looking graph? Okay, well, we'll do that one more time. So this is where you push this one into your other hand, and then it's over under we're looking at shuffle 11. So it's over, under, over, under, over, under, over. Okay. Well, I think if you do those shuffles, several times, that will convince virtually anyone and everyone out there that no one could possibly know the ordering of these cards. And that is truly a fair statement. For one thing, I could not know ahead of time what order you would choose and how many times you would have me do the different shuffles. And we did that randomization at the beginning that kind of mixed up the cards where really none of us could know exactly where we even started. Okay? So let's go ahead. What I'm going to do a little differently than we've done in the past, with some of the previous videos, what we've done is we've done the Klondike Shuffle to create pairs, and we could do that here. That would work just fine. But this time I just dealt out into 1, 2, 3, 4, into 4 piles. So what are we looking at here? So why is it that some people claim that 7 is a lucky number? Well, I don't know. Let's just see what we find. Oh, that's interesting. So those add up to 7. That's kind of fun. What about these? Those add up to 7 as well. There's no way this is going to add to 7. I mean, surely that... Oh, man, how in the world? I think we have proven beyond a shadow of a doubt that something special is going on with the number 7. Okay, so how does this one work? So let's just quickly show you how it works. Okay, so we began with this kind of arrangement. I don't know if the 3s are in the same ordering they were at the beginning and the 4s. It actually doesn't matter. Okay, so what I did was to give the impression that we're beginning to really just mix these cards and you're having a say as to how we mix them. What I did was I performed, I think it was 4 or 5, what are called the first shall be last and the last shall be first. So how this works is you just begin dealing the cards until the spectator says stop. So maybe they say stop there, and then you just keep dealing until they feel the urge to say stop, okay? Stop there, and then you put down the last card. Now it's called the first shall be last and the last shall be first, and it's because of the stacking. So the very last card dealt is the one over here, okay? So the first shall be last, the last shall be first. So you just stack in opposite order to which you've dealt them out. Why don't we do one more of these? So you just start dealing till the spectator says stop, and then you deal into another pile. Maybe they say stop there, maybe they say stop there, and then we have this 4th pile over here. So the first shall be last and the last shall be first. Now it ends up that you can do as many of these as you like. Why is that? Well, each of those shuffles of dealing them out and then stacking from right to left is actually a packet reversal. You're just reversing the order of the cards. That's all that does. Now, for most observers, it would appear to be doing much more than that, but that's all it's doing. It's just reversing the order of the cards. Now, if you do that shuffle an even number of times or an odd number of times, it actually doesn't matter. Now, if you do it an odd number of times, what will happen is the 3s and 4s will switch places. Well, that will not in any way undermine what we hope to accomplish. So it doesn't matter if it actually reverses the order of the cards. What is important for us is that these cards are still in blocks. 1 block of 4s and 1 block of 3s. Okay, that's all we need. And then from there, I use something called the triangle deal. And this is just a very clever way to convert a structure of the type that I just showed you into a Bessey packet or Bessey sequence. Okay, so this is a really fun way. And then maybe I did it a little fast, but you're dealing them out clockwise into a triangle, clockwise. And then when you're done dealing all of them, you pick up the pile that you created first in your dealing, and then you stack and counterclockwise. So just the opposite order. And that is guaranteed to do something very special with the original packet. It will convert it to a Bessey sequence relative to card values 3 and 4. Okay? So what that means then is for it to be a Bessey sequence, we should see something like, we see a 3 here, which is fine. So we should see 3, a couple of 4s, and then a 3, break. And then we should see a 4, a couple of 3s, and then a 4. So it's like having 1, 0, 0, 1, 0, 1, 1, 0. So this is of the right structure type so that the shuffles I'm showing you today, which are Bessey shuffles, will preserve this Bessey organization of the cards. Okay? So if you go through and perform any of these shuffles as many times as you like, it won't harm this. Now, it may invert it, right? We talked about that. So on some of these, so for example, the even up jog in which we stack the left pile on top of the right, that will actually invert the packet. So the 3s and 4s switch places. That's all that means. So that's shuffle 9. Shuffle 10 does not invert the packet. Shuffle 11 does invert it. And then shuffle 12 does not invert it. Okay? Now, for what we hope to accomplish, it doesn't matter whether the packet gets inverted or not. So that, which is wonderful, because that means you don't even really have to keep track of whether the packet has been inverted by a particular shuffle. Now, if you were to keep track of that, so for example, if you were to just peek, like right here, if you were to peek the bottom card here, you would know that the bottom card is 4. Okay? Now, if you've kept track of whether or not your shuffles are inverting or not inverting, if in the end you know that this should not be inverted, so what that means is that bottom card will still be 4. So the organization of the cards will still be of this kind: 3, 4, 4, 3, 4, 3, 3, 4. Whereas if you know that the packet has in fact been inverted because of the shuffles that you chose in this list of 4, then what that means is the bottom card will now be a 3. And so that would just invert it. An easy way to kind of make it look like it's been inverted is to just reverse the cards. So now we would have a 3 at the bottom, and that would tell us that we're looking at 4, 3, 3, 4, 3, 4, 4, 3. So that's just an extra credit insight I thought I'd give you. We don't need any of that for what we did in that performance. I just want to point out that inversion sometimes occurs, sometimes doesn't. Depending on what you hope to accomplish with the packet, you may or may not need that information to finish in the way that you like. So in the kinds of applications I've been showing you, we haven't really worried about whether inversion happens or not. Okay, so anyway, so at this point, what I did was I just dealt out. In fact, let's just show you that, have you think through this. Okay, so this is guaranteed to be a Bessey sequence, regardless of which of the 4 shuffles you use. Okay, so we'll have something like this: a 4, 2 3s, a 4, and then a 3, 2 4s, and a 3, or the inversion of that, where you start with a 3 here and a couple of 4s and so forth. Okay, so think about this. When I dealt it out into 1, 2, 3, 4, into 4 piles, what is that going to do? Okay, so why don't we just do it face up? Okay, so this is the top card. Okay, but I'm gonna deal it face up so you can see it. Okay, so if I did 1, like pile 1, pile 2, pile 3, pile 4. Now I'll repeat that: pile 1, pile 2, pile 3, pile 4, and you can see what's happened. What's happened is exactly what we wanted to happen. We're looking at pairs of cards whose values add to 7, and that's guaranteed to happen. So you can deal out into 4 piles like I've done in this particular video, or you can do the Klondike Shuffle and create pairs that way, which is the way that we've done it, I think, up to this point in this series. So those are just 2 of many ways, actually, to create pairs of interest to us. The pairs of interest here are ones whose values add to 7. Okay, so I think we'll stop there. There's much more I can show you, but I don't think it would be helpful to overwhelm you with too much information here. We have many more videos in this series in which I can continue to add insights and understanding to how you can use all of this to create your own amazing mathematical card effects. So thank you for watching.